So one of the things we're going to ask you to do in these practicals is to use a hemocytometer to calculate the density of cells. So when you look at something under a hemocytometer, you'll get an image that looks like this. So I've just mocked one up here. So you've got our individual cells across this grid pattern. And the hemocytometer has a very distinctive grid pattern that's always set out in the way above. So here we've got a square that we know is exactly 1 millimetre by 1 millimetre. So that's the orange square here is exactly 1 millimetre squared. So that allows us to convert our microscope image into a volume, a density of cells. So I'm going to use this square down here as my example on this one. So the first thing we need to do is to just count the number of cells in the one square. So using the hemocytometer rules, we count that one and we count that one, but we don't count that one because it's touching the top of the square. Remember, you're wanting the ones that are touching the left and touching the bottom of the square. So in that one, there are just 2 cells. And just to orientate you, that little square there highlighted in 3 is the same as this little purple square down here. So you can see if you get to the edge of the sort of main hemocytometer grid, this point that we're looking at here is the same as this point here. So square 3 is the same as one of these little purple squares. And they have a size of 0.5 millimetres times 0.5 millimetres. You can work that out from counting the divisions on there. So each of those has an area of 0.0025 millimetres squared. Okay, so we've got 2 cells in 0.0025 millimetres squared. So the next thing we need to do is to work out how many of those little squares, these little purple ones, have we got per millimetre squared. So there's 2 different ways you could do this. You could either say that to get the number of purple squares per millimetre squared, so we can just do 1 millimetre squared divided by the size of the square. So 1 millimetre divided by 0.0025 millimetre squared tells us there are 400 purple squares in 1 millimetre squared. Or we could just look at the grid and actually count them. So we've got each of these has 4 by 4 in it, and there are 5 of each of those. So along this length we've got 4 times 5 is 20 little squares, and along this one we've got 4 times 5 is 20 little squares. So if we do 20 by 20 we get the same answer, 400 purple squares in 1 millimetre squared. Okay, so we now have got a reference point. So now we can multiply up. So if we say, well, we've got 2 cells in this little square here, therefore if I want to times up to get into 1 millimetre squared, so in this orange square, then we can say that we can do 2 times by that 400, so we can take that 400 across. So we've got 400 times more in the 1 millimetre, so we've got 800 cells per millimetre squared. Okay, so we now know if we were to count all of the cells in that square, big square there, then we should get 800 of them. Okay. But now what we need to do is to work out a volume. This question is per mil, not per millimetre squared. And that's because obviously we have a volume in there. So what we've got into our we need to think about the design of the hemocytometer slide, because what we've got is actually a chamber on there that is 1 millimetre. So if we look at this orange square here, it's 1 millimetre long, 1 millimetre wide, and it's got a depth of 0.1 millimetre. So when we put the cover slip on it, we have a set depth of 0.1 millimetre. So we need to work out the volume of that thing. We're not dealing with an area. We need to take into account the fact that this is 0.1 millimetre depth. So we just need to think about this in terms of calculating the volume. So what might be useful to remember is that 1 millilitre of liquid comes from a 1 centimetre by 1 centimetre by 1 centimetre squared. So 1 centimetre is the same thing as 10 millimetres. So I have 10 mil by 10 mil by 10 mil. I get a 1 millilitre volume. So our little volume here is actually much, much smaller than that. It's in here. So this cube is 10 millimetres long, but this one is only 1 millilitres long. So we can have lots and lots of those inside 1 mil. So we're talking about volumes much smaller than a millilitre. So if we think about the dimensions of our container, we've got a width of 1 millimetre, we've got a length of 1 millimetre, and we've got a height of 0.1 millimetre. So if we do that, 1 times 1 times 0.1, we get to having 0.001 mil. in our orange volume that I've just put here. So we've got, that's a 10,000 times smaller than in 1 ml. So we can have 10,000 of these in just 1 milliliter. So 10,000 is the ratio there. So now we just need to get per volume. So we can say, so this is exactly the same on the previous slide. We've got the 0.1 to the 0, so that's 0.001 mil. So we can therefore say, if we've got 800 cells in this space in the orange square, you can see 800 cells. Well, that actually represents a volume of 1 divided by 0.001 mil. So that means that we've got actually 800 times 10,000 equals 8 million cells. Which we can also write as 8 times 10 to the 6 cells per milliliter. Okay, so we've gone from thinking about what's just happening in this one little purple square here, which is what you can see down there. We've then scaled it up to think about what's happening in a 1 millimeter squared, and then we've thought about the volume in there. So we're going to want you to be able to do those calculations. So watch the video as many times as you need to make sure that you're happy with how we get from 2 cells there actually means that we've got 8 million cells per milliliter.